we learn about optical path length. What is the difference between actual path and optical path of the wave? The actual path of the length, consider a delta x distance is covered in time t. Means actual path is delta x. But optical path length, when a wave travels a distance delta x through a medium having refractive index n. Consider a medium, a wave traveling through it, their refractive index is n. Its phase changes by some amount. The phase change by some amount where delta x dash, the optical path length or optical path of the wave, is the distance is delta x dash is equal to n into delta x, where n is the refractive index of the medium and delta is the distance travelled in vacuum. Therefore, n into delta x, that factor is denoted by the optical path of wave. Then, time is required to cover a distance travel in medium upon the velocity in medium. According to the formula, speed is equal to distance upon time. But time is equal to distance upon velocity. That formula is used, and first consider vacuum medium and another medium is any medium. Therefore, distance time required to cover to same time at the same time of both medium. Therefore, time is equal to distance covered in vacuum medium upon velocity of the vacuum medium, and distance travelled in any medium upon velocity of that medium. Therefore, we get the distance d vacuum is equal to v vacuum upon v medium into remaining factor is d for distance covered in any medium. But velocity of n, refractive index is defined as, refractive index is a constant, therefore n is equal to, in 11th standard we learn about refractive index, velocity of air medium or vacuum medium upon velocity of any medium, Va upon Vm. Velocity of air medium or velocity of vacuum medium will V vacuum upon Vm we referred as n. Therefore, d vacuum, distance of optical path is equal to d distance covered in vacuum medium is equal to n into d distance covered in any medium, n into d medium. Therefore, optical path, definition of optical path length is, the optical path length in any medium can also be defined as the corresponding path in vacuum that the light travels in same time. Hence, we take a same time. Path in vacuum that the light travels in same time as it takes in a given medium. That is the optical path length, definition of optical path length. Then, optical path length, the phase difference, the wave travels in any medium, their phases are changes by some amount. Consider the wave travel in a vacuum medium, therefore their phase difference is 0. We get a bright point. And when the phase difference is lambda by 2, we get a dark point. Therefore, the phases changes by alternate bright dark fringes are obtained in a interference system. Therefore, alternate dark and bright fringes are obtained in both sides, either not in only either side but in both sides of the central band. Therefore, the optical path length is the new concept in your textbook, optical path length, where optical path length is distance traveled in a vacuum medium is equal to refractive index multiplied by distance traveled in any medium.